Hey everybody, this video lesson is going to cover the concepts of pH, pOH, and its relationship to concentration. pH is commonly used to determine the concentration of acid in a solution or concentration of a base in solution in pOH's case. pOH is often not talked about because people don't really think too much about it, but it is something that is used to measure the content of OH in a base. This first slide kind of lays it out clearly for you. pH is the measure of acid concentration after the solution has ionized, and pOH is the measure of the base in concentration in solution after its substance is ionized. And what do we mean by ionization? Let's have a quick review. Take, for example, a little H2O, and you put some HCl into the H2O. Initially, HCl is ionic, and so it's just HCl, but now once it goes into water, it becomes an aqueous solution. Now what happens is the H plus and the Cl minus separate, and we talked about this in a previous video lesson, that when acids hit water, they separate into ions. pH is the measure of how many H plus ions are in solution, but it's not a one-for-one conversion. 1 molar H plus does not equal 1 pH. But we'll get into that. But what pH does measure is how much of the H plus really is in the solution. Not how much HCl is in solution, but how much H plus specifically. Now, one important thing we need to talk about is that in this class, we're going to assume that all of our acids are strong. And if you know the concentration of a strong acid, you know the concentration of the H plus. Now, that's not always the case. In real life situations, that's not true. In real life, the acid concentration isn't always directly related to the H plus concentration, but it is true for strong acids, and those are the ones that we're going to use in our class. Now the same goes for pOH. pOH is the measure of OH concentration of ions in solution after a base has been dissolved. Now how do you calculate pH from concentration? Well, we'll get to that in another video lesson. But for now, we're just going to talk about what is the pH scale and what does it mean. So the first thing you need to know is it's numbers ranging from 0 to 14. It actually can go below 0 or above 14, but these are the numbers that you'll see in normal, natural occurring pH ranges. Now the middle of the pH table, or the pH picture, it's often represented as a picture, is 7, and that's perfectly neutral. Water is considered pH of 7. Now everything is compared to water. Either it's more acidic than water or it's less acidic than water. Now it's important to know that when I talk about more acidic or less acidic, these terms can be interchangeable with the concepts of basicity or alkalinity. When I say something is more acidic, it's assumed that I also mean that it's becoming less basic. And by logic, you assume that if something is becoming less acidic, it's becoming more basic. Now let's get back to the actual notes. Low numbers on the pH scale are acidic, anything less than 7. That's counterintuitive. People often think as the numbers go up, it becomes more, but in fact in the pH scale, as the numbers go down, you become more acidic or less basic. Now high numbers are assumed to be more basic or less acidic. Numbers above 7 compared to water. Last thing that you need to know is that this last bottom part here. Each whole number on the pH scale represents a multiple of 10. Times 10 more or 1/10 less. For example, if you're looking at a beaker that has a pH of 5, for example, and you compare it to a beaker that has a pH of 8. So this is pH 5, that's pH 8. The first question is, which of these is more acidic? And the answer to that question is the lower number is more acidic. Now the next question is, how much more acidic is the one on the left than the one on the right? Now the difference between these two solutions is 3 pH if you take the bigger minus the smaller. Now since they're different by a factor of 3, what that means is that the one on the left is 10 times 10 times 10, or 10 to the third times more acidic, which is 1,000 times more acidic. Now instead of 8, maybe I call this next one 9. Then it's 10 times 10 times 10 times 10, or 10,000 times. If I call this 10, then it's 100,000 times. You get the idea. The greater the difference between the two solutions, the concentration either increases more acidic or increases more basic by a factor of 10. And it's important to note that if you become 10 times more acidic, you become 1/10 less basic. There will definitely be a question on the quiz and on the test about this concept. This last picture here represents the pH scale from 0 to 14. We'll start in the middle. Told you about water. Water is always the standard for comparison, and everything's either more acidic as you go to the left or more basic as you go to the right. Now, people often think that things that are acidic are dangerous to eat. Now, they can be in high concentrations, but just because it has a low pH doesn't necessarily mean that it's that bad for you. Take, for example, bananas or apples or lemons. A lot of fruits are actually pretty acidic. You know this because as you get closer to the end, they taste more sour. Lemons have a sour taste, and they get their sour flavor from the presence of acid. On the other end, you've got bases: baking soda, soap, ammonium. These are all things that are high in pH, and you don't really find these in foods very much. There are a couple things that are basic in foods. One is dark chocolate. Dark chocolate is bitter. Baking cocoa, not your milk chocolate, that's pretty sweet. We're talking about like dark chocolate is bitter. That's because it has high concentration of base in it. Notice there's not a lot of examples of things as bases as there are of things with acids in them. Bases are present in our natural world, but they just aren't useful or as useful as acids are for us. Well, that takes care of this video lesson. Thanks for listening.